Hello students, in this lecture we will discuss the repeated integral by using the integration by parts. Okay, what are the repeated integral? Okay, we will see here. It is a seventh example in the exercise 3.3. Evaluate here integral of sec cube x dx. Okay, here it is only integral of sec cube x. Okay, by integration by parts we have the two functions in the product. Okay, if inverse trigonometric function or logarithmic function, it is a single, then we take a second function, it is a 1, but it is not a inverse trigonometric function or logarithmic function. Okay, and we have to find the integrals by using integration by parts. There are a product of two functions. Here integral of u into v, it is u into integral of v minus integral of derivative of u into integral of v. Okay, here it is a u into v, but there is only one function. Now we can write this function as, see carefully, sec x into sec square x dx. Now here it is a product of two functions. Now here we use integration by parts, but in the integration by parts there is a rule for the first function and the second function. There is a rule for proper choice of the first function. Okay, it is LIATE. That means we take a first function which comes first in the serial order of this, that is logarithmic, inverse, algebraic, trigonometric and exponential. But here both are the trigonometric function. It is sec x and the sec square x, both are the trigonometric function. So which function we take the first function and which function we take the second function? Here see carefully the formula for the integration by parts, that is the integral of u into v. Here u into integral of v, u into integral of v. Here we can find the integral of the second function. Okay, and here we take the second function whose integral which are easily integrable. Okay, here we can take the second function whose integration easily available. Here there are two functions and both are the integrable. Okay, here integral of sec x, it is log of sec x plus tan x, and integral of sec square x, it is tan x. Sorry, it is integration of sec square x, it is a tan x. And here the simple integration is the function sec square x. Okay, simple integration out of two functions, both are the integrable. Integration of sec x, it is a log of sec x plus tan x, and integral of sec square x, it is tan x. Okay, then easily integrate the function sec square x, so we can take the sec square x as a second function. In integration by parts we take the second function whose integration easily find out. Okay, here we can find the integration of sec square x easily find out, other than it is sec x. It is integral of sec x, it is a log of sec x plus tan x. Okay, and it is only tan x. So it is the first function and it is second function. Now we can here apply the formula. See carefully, it is sec x into integral of sec square x dx minus integral of derivative of sec x into integral of sec square x dx, and it is a dx. Okay, then here it is a sec x into integral of sec x sec square x, it is a tan x, minus integral of derivative of sec x, it is sec x into tan x. Derivative of sec x, it is a sec x into tan x, and into integral of sec x, it is tan square x, sorry, it is only tan x dx. Now integral of sec x, sorry, it is a derivative of sec x and it is integral of sec x. Now the second step, it is sec x into tan x minus integral of sec x into tan square x dx. Here sec x into tan, we can find the integral of this term, sec x into tan square x. Okay, here this integral is not in our any type, okay, and there is, we can't substitute, but here sec x into tan square x in the integration, to find the integral of sin square x, cos square x, tan square x or cot square x, we use the formula for the function, that is sin square x, cos square x, tan square x or cot square x. Here it is a tan square x, and formula for the tan square x, it is a sec square x minus 1. Okay, now it is sec x into tan x minus integral of sec x into sec square x minus 1 dx. We use the trigonometric identity. Okay, here tan square x is equal to sec square x minus 1. Now it is sec x into tan x minus integral of sec cube x minus sec x. Okay, multiply this dx. In the second step, here sec x into tan x minus, we can separate the integral, minus, so here it is a sec cube x dx, and this minus minus we take plus integral of sec x dx. Okay, see carefully. And now here sec x into tan x minus say integral of sec cube x, and it is plus integral of sec x. Integral of sec x, it is log of sec x plus tan x, and here integral of sec cube x, again here we use sec x into sec square x, and that is this method. And then here it is a sec cube x, it is a sec cube x, it is the original integral. That means here it is a repeated integral, repeated this step. It is integral of sec cube x, again we use this step, again we use it, and then again it is a sec cube x. Okay, here इथं sec cube आहे, sec cube चं इंटिग्रेशन काढणार, याच्यात या sec cube च्या इंटिग्रेशन मध्ये पुन्हा एक sec cube आलं, याचं इंटिग्रेशन काढणार, पुन्हा एवढा स्टेप लिहिणार, पुन्हा त्याच्यात कुठेतरी sec cube येणार. ओके, म्हणजे हे रिपीट होत राहणार. इट इज अ रिपीटेड इंटिग्रल. सो वी कॅन टेक इट इज अ इंटिग्रल इज इक्वल टू sec x into tan x minus it is an integral and plus log of sec x plus tan x. Okay, here we can plus c, then after step here when we take the integral in the left hand side, here minus I, there will be plus I, so we can write it is a 2I, and then it is sec x into tan x plus log of sec x plus tan x and plus c, and therefore integrate I is equal to here 1 by 2 sec x into tan x plus log of sec x plus tan x, and it is a plus c as it is. Okay, it is an integral constant. When we can take 2 in this side, it is a c by 2, and c by 2 it is again constant. We can write it is a c. Okay, here 2I we divided by 2, therefore we can write here 1 by 2, and then last term it is a c by 2, and c by 2 is again constant. Okay, it is an integral of the sec cube x, and it is a repeated integral, same as the cosec cube x. Okay, same procedure. It is for the homework, integral of cosec cube x. Cosec cube x dx. Okay, it is an integral. Okay, same procedure. Okay, एवढ्या स्टेप करा, त्याच्यात प्रत्येक स्टेप या टाइप मध्ये यूज करा, फक्त सेकच्या जागेवर कोसेक, मग टॅनच्या जागेवर येणार कॉट. ओके, सेम. ओके, नाउ वी सी द नेक्स्ट एक्झाम्पल. ओके, हियर इट इज अ स्पेशल इंटिग्रल are in the repeated integral form. Okay, generally repeated integral is the product of exponential function and sine or cos. Here in the u into v, integrate u into integration of v, and here integral of derivative of u and integral of v. Here we can take the integration of exponential function or derivative of exponential function, it is again exponential function, or we integrate sine or cos, we can find the derivative of sine x, it is cos x, again we find the derivative of sine x, again it is, we can find the derivative of sine x, it is cos x, again differentiate the derivative of cos x, it is again minus sine x. That means if we differentiate or integrate two times the sine or cos, we get repeat as it is function. Okay, and the exponential function we can differentiate or integrate, it is as it is exponential function. So in the repeated integral, see carefully, in the repeated integral there is a general examples are the product of exponential function, that is e raised to x or a raised to x, product of exponential function and sine or cos, that is e raised to x into sine x, e raised to x into cos x, or a raised to x into sine x, or a raised to x into cos x. Okay, here x replaced by the any linear function, okay, that is into, it is a sine of cx plus d, okay, any numbers. Here it is in the repeated integral form. Okay, sine or cos, product of exponential function and sine or cos are the functions in the form of the repeated integral. Okay, now we see some examples on this. Next, it is example number 10. E raised to 2x into cos of 3x dx. Okay, here it is exponential function into sine or cos are in the form of the repeated integral. Here by the rule LIATE, trigonometric function become first function and after it is an exponential function. Therefore this integral can be written in the form of here cos 3x into e raised to 2x dx, and now here we use u into v. See carefully, u into integral of v minus integral of derivative of u into integral of phi. Okay, it is, we can write in the formula for the u into phi only, it is u into phi, u into integral of phi minus the integral of derivative of u into integral of phi dx. Now we can calculate this. Here cos x, that is a cos 3x into integral of e raised to 2x, it is a e raised to 2x upon 2 integral of e raised to 2x minus integral of derivative of cos 3x, it is minus sin 3x into 3, it is a only derivative of cos 3x into e raised to 2x upon 2, it is an integral of e raised to 2x and it is a dx as it is. Okay. Now here I can write e raised to 2x upon 2 into cos 3x minus, and this minus becomes plus, and here 3 by 2 we can write in the outside the integral, and here sin 3x into e raised to 2x dx. See carefully. Okay. Here it is the first term, it is second, and again here u into v, sin 3x into e raised to 2x. Therefore we can write here e raised to 2x upon 2 into cos 3x and plus 3 by 2 into, here again we use here u into v, it is sin 3x into integral of e raised to 2x dx minus integral of derivative of sin 3x into integral of e raised to 2x, it is a dx. Okay. Now e raised to 2x upon 2 into cos 3x plus 3 by 2 into, see carefully here, sin 3x as it is, integral of e raised to 2x, it is a e raised to 2x upon 2, sin 3x as it is and e raised to 2x upon 2 minus, okay, integral of integral of derivative of sin 3x, and derivative of sin 3x, it is a cos 3x into 3 into e raised to 2x upon 2 dx. Okay, see carefully here, integral of e raised to 2x and derivative of sin 3x, it is integral of e raised to 2x. Now e raised to 2x upon 2 into cos 3x plus, we can multiply by 3 by 2. Okay, see carefully, it is 3 e raised to 2x upon 4, 3 e raised to 2x upon 4 sin 3x minus 3 by 2, and here it is a 3 by 2, therefore we can write 9 by 4 into integral of cos 3x into e raised to 2x dx. Okay, here we multiply by this 3 by 2, and now again it is first term, second term as it is, minus 9 by 4 into, again here we use u into v, it is cos 3x into e raised to 2x, again we use u into v, then but cos 3x into e raised to 2x, it is this term, if we integrate this we get this, this, and again the last term again repeat, it is cos 3x into e raised to 2x, that means it is a repeated integral, so we can take this is the I, therefore integral is equal to e raised to 2x upon 2 cos 3x plus 3 e raised to 2x upon 4 sin 3x and minus 9 by 4 I, it is cos 3x into e raised to x, integral of cos 3x into e raised to 2x, it is I, we can write I, it is a repeated integral. Okay, now this minus 9 by 4 I we can write in the left hand side, so we get here I plus 9 by 4 I, and then here we can common e raised to 2x upon 2, and here e raised to 2x upon 2 we get, see carefully here, e raised to 2x upon 2, then here remaining it is a cos 3x plus 3 by 2 sin x, sorry sin 3x, 3 by 2 sin 3x and plus c, see carefully, we can common, it is e raised to 2x by 2, e raised to 2x by 2, then here remaining 3 by 2, okay, and sin 3x, and here plus c. Now this is, see carefully, 4 plus 9, it is a 13 by 4 I, and then 13 by 4 I, here again we can take 2 common, therefore e raised to 2x upon 4, here it is a 2 and again we get common 2, here there is a no 2, therefore in the denominator, so we multiply 2 cos 3x plus 3 sin 3x plus c, see carefully this, we can common 2, here already 2 and we get common this 2, here it is a 4, but in this cos 3x there is, in the denominator there is not a 2, so we multiply this 2. Okay, now in the last, here 4 get cancelled and 13 in the division, and therefore I is equal to e raised to 2x upon 13. 4 get cancelled and 13 in the denominator into 2 cos 3x plus 3 sin 3x and plus c. Here it is the last answer of this term. It is a repeated integral. Okay, see carefully this. It is repeated integral. Now we see the next example. Now next example. Next example, it is a exercise 3.3, question number 2 and example number 1. Again same. Question number 2, example number 1. Integral of e raised to 2x into sin 3x dx. Okay. Here it is the same as the last example. Here it is the last example. It is e to the power 2x into cos 3x. It is a sin 3x. Okay, it is the same example. It is for the homework. We can take the next example. Here it is the first. We can take the second example. Integral is equal to e raised to minus x into cos 2x dx. Okay, here we can solve. Again same procedure. It is a trigonometric function is the first function and exponential function is a second function. So here we can write integral of cos 2x into e raised to minus x dx. Now here we use the u into phi. Therefore it is cos 2x into integral of e raised to minus x dx. U into integral of phi minus integral of derivative of cos 2x into integral of e raised to minus x dx into dx. Okay, here it is a only expansion of this formula u into phi. Okay, here we can express this term as a u into phi. Then it is a cos 2x into integral of e raised to minus x. It is e raised to minus x upon minus 1. It is the integral of e raised to minus x minus integral of minus sin 2x into 2 into e raised to minus x upon minus 1 dx. See carefully. Derivative of cos 2x, it is minus sin 2x into integral of e raised to minus x. It is e raised to minus x upon minus 1. Now here this can be written as here minus this minus e raised to minus x into cos 2x. Okay, here minus e raised to minus x, this is, and it is cos 2x. This minus minus plus, but again here it is minus, so we can write minus. Okay, see carefully. Minus minus plus, and again it is minus, so it is minus. Here we can 2 on the outside the integral, and now here sin 2x into integral of e raised to minus x dx. Again here u into v, sin 2x into e raised to minus x, it is a trigonometric and it is exponential. Again we use u into v. Okay, then minus e raised to minus x into cos 2x minus 2 into here sin 2x into integral of e raised to minus x dx minus integral of derivative of sin 2x into integral of e raised to minus x dx and dx. Okay. Now here minus e raised to minus x into cos 2x minus 2 into, see carefully, sin 2x into e raised to minus x upon minus 1, it is integral of e raised to minus x, minus integral of derivative of sin 2x, it is cos 2x into 2 and into e raised to minus x upon minus 1 dx. Okay, here now it is minus e raised to minus x into cos 2x multiply by 2, see carefully, here it is a minus and this minus, it is a plus 2 e raised to minus x into sin 2x, this minus and this minus we can get plus 2 e raised to minus x into sin x, again we multiply by minus 2 into this term, minus 2 into this, it is a plus but again here minus, so it is a minus 2 into integral of 2, 1 minute, it is a 2 and again here it is a 2, so here 4 cos 2x into e raised to minus x dx, and again see carefully, it is a cos 2x into e raised to minus x, cos 2x into e raised to minus 2x, again it is original integral, that is here it is a repeated integral. Now I is equal to minus e raised to minus x cos 2x plus 2 into e raised to minus x sin 2x minus 4 into, it is I, 4 into I, then minus 4i becomes here, so here it is a 5i. Okay, it is 5i and we can take here in these two terms we can take minus e raised to x common, minus e raised to minus x, and there we get cos 2x and minus 2 sin 2x and plus c, and then the last answer here we can take this 5 in the denominator, and last answer here I is equal to minus e raised to minus x upon 5 into cos 2x minus 2 into sin 2x and plus c, here again it is a c by 5, so we can take this constant, it is a c1, it is c1 by 5, again that is c. Okay, here it is the answer of this. These are the repeated integrals. Okay, see carefully, repeated integrals are in the generally form of exponential function into sine or cos. Okay, and there is two special functions, that is the sec cube x and cosec cube x are also repeated integrals, sec cube x and cosec cube x, integral of sec cube x and integral of cosec cube x are the in the form of the repeated integral, and repeated integral generally in the form of exponential function into sine or cos, that is the product of exponential function into sine or cos. Okay, here see carefully this.